basic antiderivative integration rule. So the first rule is called constant rule. So let's say we are taking the integral of a constant value, and then with respect to x, and then this k is a constant. And then this is equals to k times x plus c, and of course c is equals to another constant. What is this called? This is called a constant rule. So constant rule. So let's say we are taking the integral of a tan with respect to x, so that is equals to tan x plus c. That is just a simple example. The next rule is called a power rule. So let's switch to a different color. So let's say we have the integral of x raised to the nth power and then dx. So the way we do this is we have xn plus 1 and then put the entire thing in the denominator and then we add c to it. This is called a power rule. So power rule. So one example that I can give you is the integral of, let's say, x raised to the 10th power dx. So this is x raised to the 10 plus 1 divided by 1 over 10 plus 1, and then you add c to it. So that is 1 over 11 x raised to the 11 plus c. So when you take the derivative of this, you can easily get the x to the 10th power back. So that is called a power rule. And then the next rule is called a constant multiple rule. So constant multiple rule. So let's say we have integral and then we have a constant times another function that is d of x. So this is, you can simply pull the constant out. So that is a constant times the integral of f of x dx, and this is called constant multiple rule. So constant multiple rule. One quick example is, so let's say we have an integral of 7 times 10 to the x. So not 10 to the x, 10 times x dx. So this one you can pull the 7 out, and then you have 10 times x with respect to x. Can you pull the 10 out as well? The answer is sure. So let's say you don't pull the 10 out, that doesn't affect anything. So the 7 is outside, right? So for the 10 times x, all you have to do is take the x. This is the first power, right? So you have a 1 plus 1 and then 10 divided by 1 plus 1. And then at the end of the day, you have a 7 over 2, right? So this is a 7 times 10 over 2. How about this? I would just put the 10 divided by 2x squared plus c, so you can easily check your work, right? So when you take the derivative of this, you can get the 10x back, right? So the derivative of that, you bring the 2 down, you get the 10x back. So we have the 10x and the 7. So that is called a constant multiple rule, or you can pull out the 7 and the 10 at the same time. So you will get 1/2 x squared, right? Okay, what is next? So, the next one is very important. I always put that on exam. So the next one is the integral of a reciprocal function. So this is an integral of x to the -1 dx. This one we don't have a name. This is the integral of 1 over x dx. So that is equals to ln absolute value of x plus c. So don't forget the absolute value. Let me just put this down. Do not forget the absolute value. Okay, so x to the -1, this you cannot use the simple power rule. Why is this true? The reason is the derivative of ln x, that is equals to 1 over x. So when you take the integral of 1 over x, you get the ln x back. All right, so and then the next one, the last one is the integral of e to the x. So switch to a different color. The integral of e to the x dx, this is my favorite. That is just equals to e to the x plus c, because the derivative of e to the x is e to the x. So that's why the integral of e to the x is still e to the x. Okay, so these are the rules. Let's do some practice. So the first practice problem that I would like to do is, I would like to do an integral of, let's say, 5 divided by x to the 7 dx. So this is the integral 5 x to the -7 dx, right? So let's apply the rule. what if you want to pull the phi out? You can do that, but that step is not really interesting. I can do that for you. So we pull the phi out, and then x to the negative 7 dx. That looks cleaner, but that doesn't really help anything. Let's do the power. So this is x to the negative 7, right? Plus 1. And then we put that in the denominator, and then put the phi up, and then we add c to it. So that is phi divided by negative 6, right? And then x to the negative 6 plus c. So this is called a general solution. How do I know this is right? All you have to do is you simply take the derivative. So you bring the negative 6 down, the two negative 6 got cancelled, and then negative 6 minus 1 is equals to negative 7. So that's how you check your answer. And then the next problem, let's switch to a different color. So how about this? Let's do a tough one. The integral 2x to the negative 5 minus x to the 10 minus 4e to the x minus x to the negative 1 dx. So that is a pretty comprehensive example. So what's the integral of the first term? So this negative 5, right? Negative 5 plus 1 plus 1. You put the whole thing in the denominator. Don't forget the 2. And then the 10, that will be a 10 minus 1. Put the whole thing in the denominator. And then the integral of e to the x is still e to the x, so that is just 4e to the x. And then how about the negative 1? Is that a power rule? The answer is no, that is not a power rule. Every time you take the integral of x to the negative 1, that is absolute value. Ln absolute value of x, right? Is the absolute value optional? The answer is no. The absolute value is required. When you are doing homework online, if you don't input the absolute value, you will not get any credits. Trust me, that happened to me when I was in my calculus class. I still remember that problem. That was a pretty long problem. I did all the work. I used a parenthesis instead of an absolute value. Guess what happened? I get a 0 because of the absolute value. I checked my answer so many times. I didn't know that the mistake was the absolute value. It turns out that everything, every little detail is correct except the absolute value. So I did a lot of work for a 0. And then since then, I learned my lesson. So when you write an absolute, when you do an integral of x to the negative 1, don't forget your absolute value. Unless you have some evidence to prove that this quantity is absolutely positive. We will see that in the future lesson, but not right now. Okay, let's clean up the coefficient. So that will be a negative, that will be a 2 divided by negative 4, right? So that is a negative 1 over 2 x to the negative 4. So take the derivative of that, you get the 2, and then negative 5, right? 1 divided by 11, x to the 11. Take the derivative of that, you get your x to the 10, and then minus 4e to the x minus ln, absolute value of x plus c. There you go. This is your final answer. Let's do 2 more. The next problem, how about this? Let's try some radical. How about the integral of square root of x plus 5 divided by square root of x plus 3 square root, the cube root of x dx. So this is the integral of x to the 1/2 plus 5 x to the negative 1/2 plus x raised to 1/3 dx. Apply the power rule. So we have x 1/2 plus 1, 1 divided by that, and then plus 5. Let's just do x negative 1/2 plus 1, 5 divided by the whole thing, and then plus x 1/3 plus 1, 1 divided by the whole thing, and then you plus c, right? So let's clean up the fraction. So this is x raised to the 3 over 2, and then 1 divided by that, which is taking the reciprocal, you have 2 over 3. The check is very easy. All you have to do is you bring the 3 over 2 down, so they got cancelled, right? And then the 3 over 2 minus 1, you get your 1/2 back. And then x to the negative 1/2 plus 1 is positive 1/2, 5 times the reciprocal of that, you get a 10. Check your work, bring the 1/2 down, you get a 5, and then 1/2 minus 1 is the square root of x in the denominator. And then last but not least, this is 3 3 plus 1 is equals to 4, right? And then the reciprocal of that is 3 over 4. So bring the exponent down, they got cancelled, and then 4 over 3 minus 1, you get your 1/3, and then you add c to it. And then with a little bit of practice, just a little bit of practice, maybe practice like 5 to 6 problems, and then you will be able to do this step in your mind. All right, let's do the last one. How about this? Let's do something tricky. Integral x to the -1 plus e to the x, and then plus x to the e dx. Is the first one a power rule? Nope, nope. If you do a power rule, you will get something you get something completely wrong. The integral of x to the -1 is ln absolute value of x. Is the absolute value optional? No, the absolute value is required unless you can prove that the x is positive. You won't see that case in this lesson. We will discuss that in the future. And then the integral of e to the x, still e to the x, and then x to the e, that is a power rule because e is a constant. It's the x raised to some power, right? So this is a e plus 1, 1 divided by e plus 1, and then you add a c to it. So this is your final answer. All right, do you like it? Is this helpful? If so, give me a like, share, and subscribe, and I will catch you all in the next lesson. Signing off.